Hi guys, welcome back to another video. A little bit of an update first. So I know that in the previous two videos I mentioned that I would like to keep doing this until someone notices. It turns out in my second video I've got three commenters. Well, now I have to find another way. Like I have to find another excuse to do this. And honestly, there's none. I just keep doing it. And even uh below the video, I mean, like in the description, I even said that I will keep doing this until uh the big schools or the big cram schools come. Uh, Obviously, I'm not gonna get high simply by this, but it's just stylistic. Oh well, I'll probably ruin the joke now that I explain everything about how I wrote. But that means I can no longer say solving MIT integration B questions if someone is in the comments because you already have. So I'll keep doing it anyway. So here we have a question from the 2014 qualifier. So you have the integral of uh, this form from 0 to 2. So if you like to give this question a go, you can pause the video now. All right, you ready? Okay, I'm going to show you how to solve this problem. So we have this integral. It might be a bit difficult here because of the seemingly infinite uh, nested radical consisting of x plus, like we have the square root of x plus inside the square root we have a square root of x plus, and then inside of that second uh radical we've got square root of x plus and so on and so forth. So basically like this nested radical goes on infinitely. So in order to solve this integral, you need to first know what exactly is this form, like what is the integrand actually. So a standard trick for this kind of problem is to assume that uh, this form itself is equal to some other letter. Why is this the case? So like basically, you see that this part of the expression is just a copy of the first part. Wait, it's just a copy of the first part. It doesn't matter that it's inside of a seemingly larger expression. Because the expression keeps repeating itself infinitely many times, we can assume that this expression in its entirety is equal to some other letter, like maybe t. So let t be equal to this entire expression. Now, this isn't actually a substitution like you usually would in previous questions. Rather, this is just to unravel what this integrand actually is. So if t is equal to this expression, notice that this expression shows up inside the radical. So you can write t is equal to square root of x plus t. And then you can square both sides. T squared equals x plus t. And now what do we have to do? We have to uh, solve this equation for t. And then the solution will be some kind of expression in x. So if we have t squared minus t minus x equals 0, so like we move x plus t to the left side, we get this equation. So now here, remember that t is the variable here. X is treated as a constant. So we can use the quadratic formula to to uh to figure out what t actually is. So using the quadratic formula, we get t equals 1 plus minus square root of 1 plus or x over 2. Right. So there are two possible answers here. We have to pick one of them. And it is clear here that we can only pick the plus sign. Why? So we assume that t is equal to this expression. Notice that t is a result of taking a square root, meaning that it must be greater than 0. So we have to pick the sign in this expression so that it is always greater than 0. So the suitable choice here is the one with the positive sign. So what that means is we can use this integral, we can use this expression in place of the integrand when solving the integral of. So let's copy the integral again. So we have this. This is equal to the integral of 1 plus square root of 1 plus 4x over 2 dx. And this is a fairly standard integral. So you have the integral of 1/2 plus integral of 1/2 times square root of 1 over 1 plus 4x. Or to make it easier for us to notice, it is actually 1 plus 4x to the power of 1/2. So this is fairly standard. So the left integral, the left term becomes 1/2 x. And then the right term here is 1/2 times 2/3 times 1/4 of 1 plus 4x to the power of 3 over 2. And we have to take this, we have to perform this integration from x equals 0 to x equals 2. So, okay. This fraction, we can actually simplify, like look at this. It's actually 1/12 times 1 plus 4x. So I'm going to replace this by 1 over 12. All right, so let's substitute x equals 2 and x equals 0 into this antiderivative. So we have 1/2 times 2 plus 1 out of 12 times 1 plus 8 to the power of 3 over 2 minus 1/2 times 0 minus 1/12 times 1 to the power of 3 over 2. So this is just 1. This is 1/12 times 9 to the power of 3 over 2, which is 9 times square root of 9, minus 0, minus 1/2. Oh, sorry, 1 out of 12. So you get 1 plus 3. We cancel out 9 of 12, and then the square of 9 evaluates to 3, so that is out of 4 minus 1 out of 12. So here we have 12 plus 9, 12 divided by 4 times 9 is 27. Wait, no, not 27, is it? Yeah, it is 27. 27 minus 1. So you get 12. What is this? 39 minus 1, 38. 38 over 12. This evaluates to 19 over 6. Did you get it correctly? Let us know in the question in the comment section below. So yeah, that's the integral that we're solving for today. See you in the next video.